All right, thank you. So I'm going to talk about smart data, and one of the things about smart data is to realize you don't only use it, you create it. So let me do a little bit of that. So wave. Oh, you're not waving, that's sad. All right, so there we go. Hopefully that works. Leave it to Twitter to mess that one up for me. So tweet, data, here we go. First tweet of the morning there. So, thank you very much. Thank you, Elena. Thank you, Maya. Thank you, Emmy, wherever you are, Jesse, the whole dream team for this event. Thank you to the sponsors, who many of them are over there and up there. Make sure you visit them. They have cool toys to give you, a lot of great information and products as well. So this wouldn't be possible without all those kinds of people. So today I'm going to talk about smart data, but it includes in the presentation, the latter half, sort of my view of the top 10 trends in data science and machine learning. Okay, so moving towards uses of data in smart ways is one thing, but actually creating smart data, which is giving smartness to your data, is what I'm going to start talking about here. So let's just get going, because there is a countdown clock, and I'm told that after exactly 30 minutes, they're turning the microphone off and music will be played. So if I run out of time, all of a sudden my mouth will be moving and you will hear music. It's not me, it's them. Okay. So first, let's talk about how we got to where we are today. First, came data, then came big data, now comes smart data. Talking about that as the fuel for our algorithms and our applications, and then get into this sort of top 10 trends. So hopefully this all will work in a 30-minute stretch. Anyone who knows me knows that my 30-minute talks sometimes go 31 minutes or 31 hours, whichever comes first. So first came data, then came smart data. So ever since we first explored the world, we as human beings are curious creatures. We always explore things and ask how things are. We look at the world around us, and when we say to ourselves, why doesn't the clicker work? And then we ask questions: why, what, how, what is this, and why does it work this way? How does it work? And the more questions we ask, we want to collect more information. So humans are really good at collecting evidence to answer their questions, and so this evidence we now call data. So we ask questions, and we collect data about the things that are around us. But most of the time, we sort of end up in this predicament, like hopefully you've seen this cartoon before, the blind men and the elephant. So each one of these blind people is feeling a different part of the elephant. One person is feeling like the tail. One person is feeling like the trunk. One person is feeling the whole body of this big, huge animal. And that's all they know about that system, that very complex system. And it's something completely different for each one of them. So if you ask each one of them to describe what this complex system is, you'd get a different answer, because they're each acquiring different types of data about it. So we are confused, so we ask more questions, and more questions lead to more data collection, which leads to more questions, which leads to more data collection, well, you get the idea. So this is how we get to big data. Because we have insatiable curiosity, we want to collect as much information as evidence and data as possible to understand our complex systems. So the question that comes up then is, does this really help us? Having all these extra sources of data, if we keep them in data silos, which a lot of businesses and organizations do, they have the HR data, they have the operations data, they have the sales data, they have the marketing data. They have all these different silos of data, and if you do not integrate these data sets, then you're pretty much in the same situation as you were before. Each person or each part of the organization has some limited view of the whole thing and not really knowing what the whole thing is doing or what the whole thing is about. So when we end up in this predicament, we have to do something, and the way we do that is break down those silos. We start looking at various interesting combinations of all those data sets, relationships, correlations, associations, linkages between all of those pieces of data. So what you end up is not with big data, you end up with something else. So if you notice the axis on this plot here, the y-axis is called the holy shoot axis. I think you know what I mean. So linear data growth, we know that that's not what's happening in the world. So the very little purple curve at the bottom there, linear growth, doesn't look like growth at all. exponential growth, everyone likes to say, oh, wow, data are growing exponentially. How extremely fast that must be. Well, actually, it's kind of tiny, actually. Okay, the real growth curve, that's the holy shoot curve, the red one there, is the combinatorial growth curve, which is when you start looking at all possible combinations of your data. So I like to use the example of, say, 26, let's say you have 26 features in your database, whether you have customers or machines or objects or entities of some kind in your business. How many of you have more than 26 features about objects or feature or customers in your data? I hope all of you do, because that's the whole point of feeling that elephant out, feeling your complex system. You think of all the data sources just about the human body, or in a system, for example, a manufacturing plant, or in a car. I mean, there's sensors everywhere. There's many more than 26, but I like to use 26, and you'll see why in a second here. So if you have linear growth of data, all right, so you have so much data today, and if it's just linear growth, let's say the factor of 2, we have 2 bytes. So by linear growth, after 26 steps or 26 time periods, you'd have 52 of that, 2 times 26. All right. If you have exponential growth of data, which we do have exponential growth of big data, the volume of data, and as it says in the little plot up there, volume is the most annoying part of big data. It has nothing to do with big. It has to do with a value that you can extract from data. So 2 to the 26th power is about 60 million. All right, so let's just say you're going to analyze some data, and you're going to do some, let's say, some principal component analysis. And let's say it takes you basically sort of like 1 second, let's just say something like 1 second to do one of these PCAs for each of these features in your database. All right, so if you have 26 million of those things you're going to check, let's say, then 2 to the, so 26 million, I should say, 2 to the 26 power is 60 million. That'll take you 2 years. There's 60 million seconds. It will take you 2 years to do that. But now let's look at all possible combinations and associations of those 26 items. Okay, do all pairwise combinations, A with B and A with C and A with D, all the way through A through Z, and then B with C, B with D, and all B through Z. And all of those 26 combinations, that's 26 factorial. Okay, so combinatorial growth, it goes as x to the x. X factorial is approximated by x to the x power. So if you were to do just look at the data as it is, and 2 to the 26th power, that would take you 2 years to analyze all of that. But if you were looking at all possible combinations of 26 things, it would take you 10 to the 9, 1 billion, that's 1 with 9 zeros, 1 billion lifetimes of the universe doing one of those per second. So something as small as a database with 26 columns and maybe 100 rows, or maybe even a couple hundred rows, or even a couple thousand rows, it's not the number of rows, it's not the volume that kills you. It's the width, it's the number of combinations. And so how do we solve this ridiculous problem that even for a very tiny little data set, it'll take us 10 to the 9 lifetimes of the universe just to analyze a tiny little data set to find all possible interesting connections and associations and patterns and trends and correlations in 2 dimensions, 3, 4, 5, all the way up to the 26 dimensions. And oh, by the way, if you're like a lot of us, I mean, even 15 years ago, I had data sets where I had over 1,000 features in the database. 1,000 factorial, 1,000 to the 1,000th power. I can't even imagine the computational power of a infinite number of parallel computers could even attack that problem. So the way we deal with this is to realize that the fundamental problem is our data structure. The fundamental problem of our data is we're not dealing with it smartly. All right? So the natural data structure of the world is not Excel spreadsheets. Right? The natural data structure of the world is not rows and columns. It's graphs. Even this famous playwright William Shakespeare said, all the world is a graph. Well, actually, he said, all the world is a stage, if anyone knows the quote. Okay, so, but stage is okay because I've actually asked my company to maybe we start developing this graph analytics engine. It's going to be the Spatial Temporal Analytics Graph Engine, STAG, stage. Okay, so what's important about all of us and things that we deal with is the things themselves, the people, the entities, and their relationships with one another. That's a graph. It's the relationships between all those bits and bytes of data that help you to understand the system. Just going back to our elephant picture, but think about that elephant picture as a picture of an organization which has data silos, and now you break down the silos and you start comparing trends across the different databases within an organization, looking for connections, co-occurrences, co-associations, co-correlations among 2 at a time, 3 at a time, 4 at a time among those data sets. And when you start looking at it as a graph, then all of a sudden the really important edges in the graph become visible, and those are the things you focus on. So instead of focusing on 26 to the 26th power, 26 factorial basically, number of combinations, you can focus on the ones that are most important, the most significant edges in the graph, because it's all about those relationships between the entities that's really the most important thing in the world. So what makes our data smart is to not only look at it this way, but to add to the data itself. Okay, so we are not only users of data, as I started off by saying, we are creators of data. So if you're tweeting in social media, you are creating data about this conference that people in the world can see. You're also creating a digital trail of where you are. And not only your digital trail, but a lot of other people who are tweeting with the DN2017 hashtag, we can see a correlation of a bunch of people in Berlin all attending this same event today. So we see this correlation between the data sets, and it's unified, that story, that experience is unified through a single hashtag. So think of the hashtag as metadata describing your day here, but not just your day, but many people's day here. So think about creating hashtags. Now, I don't mean hashtags necessarily in the social media sense, but metadata tags. Now, when people think of metadata, they think of boring subjects like, oh, you mean like administration information, like what date and time was this data set created? Okay, that's important, but that's not what I mean. What I mean by smart metadata is information about what is the content of this data granule. What is the meaning of it? What is the context? Where, when, how did it happen? Under what circumstances was it created? Under what circumstances it was used? Even use cases, how people have used this data set is metadata. So in science, we usually end up doing research on our data, and we publish research papers in journals. A research paper is metadata. It's a description in human consumable words about the data set, the discoveries made against the data. Now, you may not think of a 20-page article written in very technical scientific language as metadata, but it is, because it fully describes the content and context and discovery and knowledge embedded in the bits and bytes that scientist analyzed. So the more we add these connections, these relationships, these metadata, these smart tags, the digital trails, how and when and where and why did you create this and use this data, then we're adding value to our data set. So now we can find all possible other data sets that were created at that time or in that context or by that person or for that use case, and now our data becomes smart. That is, we're not just querying databases for data, we're querying databases for knowledge. And that's what we really want to do, okay? We want to go from all those ones and zeros and bits and bytes to a higher level of abstraction, which is what we're all trying to achieve, is knowledge and understanding from our data. It's not so much that I want to see the bits and the bytes and the ones and the zeros. Of course not. I want to see the knowledge and understanding that's represented in those bits and bytes, and that's the smart data. So guess what's going on? What's going on is essentially the same thing that's happening in our brain, and this is not too surprising, because we collect data to understand our world because we have a brain that understands our world. So we go out and ask questions and gather evidence as human beings. Ever since the first human beings crawled on the earth, we're collecting data now to answer questions. So what we're doing is no different than what we've always done. It's just way more digital, way more technical than it ever has been in the history of the world, but we're just emulating what we naturally do up here. And so the human brain is really good at making connections between things, and we call them neural pathways, and there's projects that work on these smart brains and building the brain, so to speak. And that's what we're trying to build in our systems, is this smart brain infrastructure. So with machine learning, we're emulating what humans do automatically, which is learning from their environment and learning how to understand and to move about our environment, whether it's a smart vehicle or it's a medical doctor, or it's a machine, or it's you. We're all trying to figure out what's the next best thing to do. And so there's lots and lots and lots and lots and lots of applications of smart data, and I list some here from a conference that happened earlier this year. I'm not going to read this long list, but you can imagine there's lots of applications, lots of opportunity. So there's no end of wonderful opportunities in this space. So the fuel for all this is data. None of this is possible without data. We are today where we are today because we have massive volumes of data. Okay, so databases have existed for many decades, okay, since the 1970s, formal databases, but data have been collected for a long time. Machine learning and AI algorithms have been around for equally long years, 10s, 20s, 30, 40 years. So what's the big difference? We've had data all this time. What's the big fuss all about? The fuss is we have way more data. We have way more sensors on that elephant, if you will, than we've ever had. Way more sensors on our customers, on our processes, on our products, on everything than we've ever had before. And by breaking down the silos and looking at the relationships, connections, and the correlations among all those things, we're building way more intense, complete pictures of that elephant, whatever your elephant is. And so we have huge amounts of data. We have amazing algorithms, new ones coming out all the time from amazing startups, and we'll be hearing from some of those today and tomorrow, I imagine. And also we have the powerful computing that we've never had before. So now you can have the power of a supercomputer for your very self through a cloud service. I don't have to buy a supercomputer. I can rent one for a couple minutes from Amazon and then give it back to Amazon. I don't have to buy one. So businesses, organizations, and industries now are using the cloud because they only provision what they need and then they give it back. Instead of buying a machine that will go obsolete in a few years, provision one. Buy the service from a cloud service provider, do some heavy computing on it, and then give it back. So we have all these capabilities which now enable us to be where we are today, where the whole world is on fire with data analytics, and trying to do discovery. And so the fuel is growing in volume, and one of the ways it's growing is not just in the ways we've already been describing, but in coming soon, already here, the Internet of Things. So the Internet of Things provides many, many sensors of information about your environment, about your car, about your home, about your health, about whatever. Okay, so these sensors are sensing its environment and feeding more data and more fuel, if you will, to our algorithms to make us smarter, to make our machines smarter, to make our world smarter. And so I like to think about the Internet of Things as also providing context, contextual information about what you're doing. It measures the temperature, the traffic, the time of day, the number of people in the room, the number of customers who bought this product, what was going on in the world when the customers were buying this product. Was there a sporting event, a political event, an economic event? Okay, so all those metadata tags, all those signals coming in from the sensors provide context to your algorithm, to your calculations, to your problem you're solving. So I like to call Internet of Things the Internet of Context, because now it gives you all those associations and connections between the signals you see. What else was going on when that happened? What might have caused this to happen? So we have all that contextual information, and it enriches and smartens our data. So now we can do all kinds of smart things, predictive this and precision that and personalize this. I mean, it's all over the place. People talk about all these things and probably many more than that. You know, the Internet of Cows. Have you seen the article on the Internet of Cows? I mean, it actually exists, right? So cows have sensors on them the same way you have a wearable device to measure your heart rate and all kinds of other things. They can tell when the cows are ready to give birth, whether the cows are ready to lactate. It's on and on and on it goes. So there's smart, predictive, precision, everything. So moving right along, because the clock is moving. The clock hasn't stopped since I've started, so I need to keep moving faster. Okay, so our smart data comes from having all of these information-rich sources of data and connecting them together, and hopefully adding some links in that graph. Okay, so we build this graph, and they say, you know, John used this data set to solve this health problem for this patient who's suffering from this disease. And now you start building the graph of all possible health treatments in an organization, and you can start seeing patterns and trends. And maybe you discover that a lot of people are getting sick in this process, and you discover all of a sudden that a lot of these people are being prescribed two medications which badly interact with one another. All right? So you might not actually see that anywhere in a database table, because different doctors in different departments, maybe even different hospitals, are prescribing those medications. But if you see the the journey, the path of that patient, you'll start seeing those edges grow. And so those are among the top trends in data science and machine learning. I'm going to go through them fast here. There's 10, and I got exactly 10 minutes left, so let's see if we can get done in 10 minutes. So the Internet of Things. Okay, why would I say this is a top trend? Because people have talked about this for several years already. People like to say the Internet of context, the Internet of analytics things, the analytics of things, all kinds of phrases about Internet of Things, but again, my favorite way of describing it is Internet of context. It's now giving us context about so much more in our world than we've ever had before. And there's a really interesting book on this topic called The Age of Context, and I encourage you to look at that. Hyper-personalization. We've had personalization for many years. Amazon and Netflix and many organizations will recommend books or movies or products to you. So I don't think there's even an online e-commerce store in the world nowadays that does not have some kind of recommender engine. And Amazon is a perfectly good example. 30%, practically 1/3 of their revenues come from the recommender engine. 1/3 of their multi-hundred billion dollar business comes from people clicking on a recommended product, which was put there, that ad was placed there, that product was placed there by a machine learning algorithm. So now we've had personalization, so why hyper-personalization? So hyper-personalization is now very specific to where you are, what you're doing, when, where, why, how, and all the data sources, whether it's through this device, which is the most amazing data generator in the world, your smartphone, especially if you have location turned on. I have like 60 apps, and I'm afraid I must have that location turned on for most of them. So all these apps know where I am and when I am, okay, and what I'm doing. Okay, so hyper-personalization, the digital exhaust. So even if I just say, hey, welcome to Data Natives, I mean, I'm leaving a trail of where I've been. Okay, so all this data now makes possible more precise marketing for your products and your interests. Now AI, so what AI? Like I said, some of these things may sound not new, artificial intelligence, but I'm not talking about artificial intelligence, I'm talking about augmented intelligence. So most people I talk to in conferences these days, and believe I go to a lot of conferences, they're talking more about augmented intelligence, assisted intelligence, machine assisting human and human assisting machine. Okay, so the call center person. Okay, so there's a chat bot there carrying on a conversation with you, and you end up with a complex question that the chat bot can't interpret, so it hands it off to the agent. And so traditionally what would happen is the agent would start all over again. Well, what's your name? What's your account number? And say, what's your problem? And you just spent 20 minutes saying those words over the phone, now to a bot, of course, but you don't want to repeat all that. And so the agent can now be informed not only about those things, but about your purchase history, your complaint history, your product history, all kinds of things about you. So the machine is assisting the agent. And vice versa, the agent can then turn the conversation back over to the bot after you've solved the complex question to deal with maybe some simple things like changes of address or phone numbers or something. So it works in both directions, and we're not building bots to take over the world. I mean, I was telling them in my workshop yesterday, people, how many people use like text messaging? Raise your hand, everyone in the room. And so you probably have autocomplete on your phone, right? So you're typing a word and it completes the word for you. And does that work perfectly every single time? No, I see some heads shaking. No, sometimes it's pretty embarrassing, right? Okay, so autocomplete is using a machine learning algorithm to predict what the next word will be. All right. Okay, so sometimes this doesn't work too well. Okay, but even though it doesn't work too well, I have yet to see any autocomplete on a text message take over the world yet. Okay, so AI is augmented intelligence, assisted intelligence. The next thing is machine intelligence, where we're actually automating processes, automating things in our businesses, even identifying people in images, behaviors in images, in text, and audio, whatever. Machine intelligence is automating much of our business using these machine learning algorithms and these AI applications. So these augmented and assisted intelligence applications. The next one I have here is AR, so augmented reality. Again, you might keep going down this list. You keep saying to yourself, maybe, and I'm saying to myself, you're probably thinking, wait, this has been around a long time. Well, AR, augmented reality, is no longer just a toy. It's being used in training. It's been used in disaster response. It's been used in all kinds of applications where maybe you put the goggles on and use. So it's not virtual reality, but it's augmented reality. I still see the room. Okay, I don't have them on, so don't panic. Okay, so if I had them on, I would still see you, I'd still see the room, so when you raised your hand to ask a question, I would see a little Twitter feed right here said, oh, this person just said he loved my talk, so I thanked them for that, and this person says she didn't like my talk, so I'll ignore her question and go over here now. But in disaster response, recognizing from behavioral analytics the motions of people, who's in distress during maybe a major accident. Which person in this crowd is the one who most needs medical attention by either their facial expression or blood or the way they're walking or something? The app can identify that person. Training people. So I know about a military application where they're training Air Force personnel to load very large planes. Okay, so they're actually walking through the environment of the plane and they see the plane, but projected in front of them are these different loads that they have to move. They're not really moving anything, but it looks like they are because it's projected in their space. And they learn how to place heavy loads in the right places in order to build it correctly. Anyway, so on it goes, all kinds of disaster response and training and education, many applications coming down the pike. So behavioral analytics. So now remember what I said all along is that all the data we've ever collected since the beginning of humanity to help us to understand our world and our place in the world and how we move through our world and interact with our world. Okay, so data is now giving us signals of how people interact with their world, how people behave, what they think, what they're doing, where they're going. So this behavioral analytics can help you to understand customers, can help you understand cyber actors in your environment. Are they cyber intruders, or are they normal users of your cyber environment? So we're seeing behavioral analytics applied in marketing. We're seeing behavioral analytics applied in cybersecurity in many different places, modeling this. So the one graph I added to the list here, there's the graph, the Maslow hierarchy of needs. People know about this at all? So basically, it's just a fundamental psychological statement of how people are actually motivated. They're motivated by physiological needs, to be fed, safety needs, belongingness, love, esteem, self-actualization. These are real. They're there, regardless of whether you have analytics or not, whether you're educated or not, whether you're living in the 21st century or the 2nd century. This is what motivates, drives people. And we now have signals about it, again, pointing to this device, our fundamental universal device to understand you. Okay, we can model those behaviors and improve our marketing campaigns, improve our health treatment options for patients. We can improve even behavior of machines, identify symptoms of machines that are likely to break or have trouble. So behavioral analytics applies not only to humans, even though that's mostly it, but you can imagine the same sort of thing beyond humans. So that we're actually able to do this now because, again, think about the blind man and the elephant. We have so many data sources about customers or about patients or about whatever entity we're studying. So then we put all this on the graph. Okay, so graph analytics is now really exploding. We're seeing many, many more applications of this, even a lot more conferences I'm seeing on graph databases, graph analytics, graph-related things. So whether it's an influence graph or a product graph or a social graph or whatever, it's the relationships between things that are important. So you can apply this in root cause analysis and machine failure. You can apply this to marketing attribution. You can apply this to money laundering and human trafficking, where you start seeing the connections between things and identify, what's the significant pathway in that graph. Okay, so for example, in money laundering, you have a transfer of money from A to B and then B to C, and maybe A to B is legal and B to C is legal, but A to C would be illegal. All right, so that's why it's called money laundering. It goes through a third party. So you would never see the money laundering in a traditional transactional database, but you would see it in a graph. Number 8 is my favorite, the one I loved the most this year, Journey Sciences. So Journey Sciences is putting all this together and creating the journey of the customer, the journey of the machine, the journey of the patient. So people who heard my workshop yesterday, the journey of the killer asteroid. So if we detect an asteroid in the sky, we collect data, we build a descriptive model, then we can say, okay, from that data we can build an orbit, which is a predictive model. We can say where it's going to go, and then we predict that asteroid is going to impact Earth and destroy civilization next Tuesday. Oh dear, can't you do something about it? So once we have this journey, we understand what are the conditions and forces that move things around, whether it's your customer in your marketing campaign or your patient who's dealing with a scary disease. Move things around in that space so you end up with a better outcome than the scary one. experience economy. Okay, so we're seeing not only just customer experience and user experience, but employee experience, digital experience. Okay, so the economy is now about how are people interacting with your data, with your app, with your business, with whatever they're doing, and because it's, again, about human beings interacting with their world. And the last one in this is agile or data ops. That is, do all this thing as agilely as possible, fail often, fail fast, because that's how you learn to do better the next time. So it's incremental and iterative. So moving right along, here's the summary of all that. Doing all these things and applying these top trends to your data will deliver deeper insights from your data, and then that's really being smart. Okay, so finally, let's get smart. So let's not think about our data as a relational database where you have, just entities disconnected. Let's connect them all together and build knowledge, not databases. So let's exploit all these top trends in AI and machine learning and data science to really make the most of our data. So thank you very much. The music hasn't started. Thank you.